Hi, in this section we look at the normal distribution. It is the most popular distribution in statistics, partially because it models so many situations and data sets. It's also called the Gaussian distribution. It was founded by Carl Gauss. Here's an example. Suppose that the volume of a can filled with soda is modeled by this density function. So this is just our f of x, but in this case f of t. We're going to let capital T represent the volume, and this is just then a density function, f of t. It's defined for all real numbers, so once you get past 0, there's almost no probability. Just as we did in the other section, if we want to find a probability or a proportion, we're going to take this density function and then just integrate over a certain region to find that probability. So this one right here, I'm going to go ahead and graph this in Maple, and then we're just trying to find the proportion of cans that have volumes less than 12 ounces. So I'm just going to integrate up to 12. So if I go over here to Maple, I already put this function in. It's right there. All I do is type what it had on the other page. And what I'm going to do is integrate. Well, let's plot it first so you can see what it looks like. F of t from 10 to, let's say, 14. And there's the graph, right? And you can see this, it's centered close to 12. And let's find, integrate f of t from t equals, did we say, I think we said at least 12. Let me see. What's the probably, contains less than 12. So let's see, less than 12, 0 to 12. And you might wonder why I'm putting 0, but it really, right, it doesn't make sense to have a fill less than 0, but you can also see there's no probability over there. So I'm not really doing anything illegal. I'm thinking of the problem situation, and that's not going to happen. So I'm not worried about that. So now we define exactly what the density function of a normal looks like for any normal with a mean of mu and standard deviation of sigma. So let x be a continuous random variable, and let's go back up to this. Here, right here is my standard deviation, and right here is my mean mu. So a normal has two parameters. One is the mean, and the other is, well, actually he squared it here, so that's the variance. Standard deviation is the square root of that. It's often written x has the shape of, that's what that symbol means, has the shape of a normal distribution with mean mu and variance sigma squared. Be careful, sometimes I forget and I'll use mu sigma, where sigma represents the standard deviation. So I'll be very careful to always try to put in there the variance. Nicely, this function, and you could tell from above and other bell curves I'd made, this is density is symmetric about its mean. And so what I mean is, there's my curve. Let's put mu here, and notice I have across the mean symmetry. Approximately 95% of the area under a normal curve, if you put a mark here in both directions, actually is within 2 standard deviations. So if you go mu and add 2 standard deviations, and mu and subtract 2 standard deviations, you have about 95% of your data. So down here, approximately 95% of the mass is within 2 standard deviations. We use this model often for modeling noise, air, if you're an electrical engineer, and any kind, right? Modeling errors, normal is very popular for. And let's see, I think we have, oh, he's just showing us how to view this normal curve in Minitab, but we'll do that in the next example. So here's an example. This is the thickness of aluminum sheets. So we let, here's thickness. Let's go ahead and let that random variable be x. And we're told that it can be modeled by a normal. So right now we know x is the shape of a normal with a mean of 10. So here's mu, and a standard deviation of 1.3, that's sigma. So I'm going to put 10 and 1.3 squared, the variance. Okay, and now we're just going to answer questions like we did in the previous section. So what's the probability that we grab a sheet and it's greater than 10.8 thousandths of an inch? So if we draw this, and the center, that's just the dog, the center is 10, and I'm finding the probability that I have a sheet that's bigger than 10.8. The picture's not necessarily drawn to scale, so I'm just trying to give you the overall shading idea. So let's go head over to, I'm going to Maple. I put this in before I started because it always takes a while. So there's 10 and 1.3. There's my probability density function, and I always just check that it integrates to 1, so I didn't, it's so easy to make a little mistake with the square or with the square root, so be careful that it's still legal and that you typed in the right function. Okay, we're good to go. We wanted the probability that it was thicker than 10.8 inches. So I put this in and I get a probability. Oh, what do I have wrong? Oh, x, I forgot my x equal 0.2692, so we have an answer for that. Next question, what proportion of sheets is between 10.8 and 11? So all I have to do is go back to this computation, and I'm just going to put an upper bound of 11 instead of the function being integrated to infinity. I'll just put 11 here, and I get about 0.0483. Next question, what proportion of sheets differ from the average plus or minus 0.75 of an inch? 75 thousandths of an inch. So what I'm going to do is, so 10, our center was 10, so 10 minus 0.75 and 10. Wow, this is stupid, right? If I can't do this in my head, I'm in bad shape. So I'm going to integrate f of x from x equal 0.75 in the left direction and 0.75 in the right direction. So 4360. And last question here is find the value that cuts off the 5% of the sheets have a value that's less than that value. I said that really terribly. So let's go back to my curve. I'm trying to find that value. I'm writing on my screen the wrong one. I'm trying to find that value, which we called in the last section Q, such that it cuts off the least 5% of thicknesses. So we would say we're trying to find the fifth percentile. So you can use, capital F, the cumulative distribution function, but I still like just integrating and solving in Maple or Minitab the following integral. So 0 to what value Q of f of x dx, which we have the f of x up there, equals to 0.05. And all I have to do is put this in Maple and solve for the value Q. So that's what I would do. Now going back, we could do all of this in Minitab, and I think that's the last thing I'll do, and we'll go on to the next example, but I can do this all in Minitab. So this is really, really nice. You want to make sure that you understand this. I go to Graph, and a very nice function is probability distribution plot. And I want to view a probability inside a curve, so I push view probability. It has all the standard distributions listed here, with normal being the most popular, so that's our default. You put in the mean. It requires the parameter of the mean and the standard deviation. And so right now I could just have it draw that. So let me just push OK. I get a drawing. Oh, automatically it put in the value that cuts off the top 5%. I'm not sure why it just did that on its own, but okay. So back to the menu. I really want to find a shaded area, and I want to put in the value that I want to find the shaded area past. I want to find it in the right tail, so I put 10.8, and I say OK. And 0.2692, that's what we had computed in Maple, so this is the same value. So Minitab's really just doing the integration for you, and it's shading the portion so you know what area goes with which part of the graph. The next one, I just go back to this box to say, hey, pull up the last dialog. I want a shaded area again, but I want the shaded area in the middle of 10.8 to 11. I say OK, and that's about 0.04827, which we had found out in Maple. The next one was to the left and right of 10 by 0.75. So I'm going to say both tails. How do you, oh, okay. So, well, I'm going to do this way. Why would I? This is going to find in the middle, so 9.25 or 10.75. And now I just have this worry that maybe what proportion of sheets from the average, what proportion of sheets differ from the average thickness. Oh, so it's actually asking me for the proportion outside of 0.75, and I found the proportion inside of 0.75. But that's easy to take care of, right? All we have to do is 1 minus the value we found over here. So let me go back to Maple. Right, we found the value between 0.925 and 10.75. If I want to find at least that far away, I'm just going to subtract from 1. So same thing over here. This will find the middle, which I might as well do first. And it shows me this value and subtract it from 1, and I have the proportion more than 0.75 away. And the thinnest, wow, I'm on the wrong screen. Let's go back here. Oh, yeah, we were doing that mini tab. I want to cut off the thinnest 5% of sheets. So let's find this value Q that leaves 5% in the left tail. I go back, pull up my dialog box, shaded area. I'm given a probability. I want to find a probability, the quartile or percentile value in the left tail. So I put in the probability that I want that value that only leaves 5%. So you're putting in a percentile here. And the value that only leaves 5% in the tail is 7.862. And so that's actually, I have other videos here too, but I think now you know how to work with a normal and Maple and mini tabs. So really you have the gist of this section, and the rest is just adding some more examples. But that is the main point of video 3. So if you want to, keep going. If not, I think that's a pretty nice introduction, and if you could read through the rest yourself or whatever you want to do. I'll make another video just to keep going and finish the notes.